Hi, this is Miss Carly, and this is your flip video for 4.2 Key Features of Functions. What I have behind me is a piecewise function. You can tell because it's in pieces. We have two linear pieces, and this one is probably a quadratic piece. In this unit, we're talking about key features of functions, which is basically all of these things. Domain, range, where your function is increasing and decreasing, where your function is positive, greater than 0, or negative, less than 0, if there are any maximum or minimums, and the x and the y intercepts. Now, the only difficult thing about these key features is there are so many of them, and it's going to be a little bit different for every single function. So that's why your homework over the weekend is to be looking at some of those parent functions and trying to find a few main ideas and some of these things for your parent function so that you can have a little bit more knowledge when you come to class on Monday. All right, so let's focus on the domain. Anytime the question is asking you to describe the domain, it's asking you for the range of x's from all the way to the left to all the way to the right. You always start left to right. So if you look at my left, this arrow is going towards negative infinity for my x's. So this arrow is going to continue all the way to the left, which means it's every single x value that's to the left. All right, now let's trace it. I see there's something funky going on at -1. I definitely have a gap in my graph, but this open circle means that -1 is not included for this piece, but it is included for the top piece. So -1 is still in the domain because that's a closed circle. If you move on, all of these x values are good. When I get to +1, this open circle means that it's not a part of this function, but the closed circle means that it is a part of this function. So 1 is included because this is closed. And then my graph is going to continue towards positive infinity forever. So basically it's going from negative infinity to positive infinity, which means it's the set of all real numbers, and that's what that fancy R stands for. All right, your range is the y values. Usually the range describes from the lowest number to the highest number. So if you look, I'm going from negative infinity over here, negative infinity over here. So that means your y values that are below the axis, it's just going to keep going down forever and ever and ever. All right, if you look at the y values up here, all right, I have a gap in my y values in between 1 and 2. But it's the y values for the whole entire graph. So if you look at this piece still covers those y values. So even though there's a gap here between 1 and 2, this will take care of those numbers. Those are included in here. If you were to trace this, you could find the y values between 1 and 2 over here. All right, I also have a gap between 2 and 3, but again, this piece is going to cover all of those numbers. But if you notice, I don't have anything above 3. So basically, 3 is the highest point on my graph, and my entire function is below 3. So I'm going to write that as all of the numbers that are less than or equal to 3. The other thing that you could write, you could say from negative infinity to 3. You could write it like that, and that would be fine. But as long as you understand that the only y values on this graph are 3, and all of my other y values are less than 3. All right, where is your function increasing? Increasing means as you look at it from left to right, it's going up. Your y values are getting bigger. So the only place where if I go from left to right, I'm going up the graph is all the way down here forever and ever and ever. As soon as I trace it up until I get to -1. That's the only place that from left to right, it's going up. If you notice here to here, it's constant. It's not increasing. It's not decreasing. And once I get to 1, if I trace to the right, I'm going down. So this means that this piece is decreasing. So I'm increasing all the way to the left, which is negative infinity, up until -1. Then I'm constant for -1 to +1. And then I'm decreasing from 1 forever until infinity. So that's these two. All right, notice between -1 and +1, there's a gap because that's constant, so it's neither. All right, this looks similar, but this is actually asking you for when the y values are bigger than 0. So that means your function is positive. And when your y values are less than 0, that means that your function is negative. So pretty much you can just draw a line across the x-axis. And everything above is greater than 0. And all the little pieces that are below are less than 0. So my graph is above the x-axis. That means my y's are positive. Everywhere from -2, all right, all of these y's are positive, all of these y's are positive, all of these y's are positive, up until I get to 2. So everything between -2 and +2, all of that is above the x-axis. So that means that my function is positive. It's greater than 0. So that's between -2 and 2. All right, where your graph is less than 0 means all the pieces that are below the x-axis. So I'm under the x-axis from -infinity all the way to the left up until I get to -2. That piece is under the x-axis, so it's negative. But I also have a negative piece over here that goes from 2 all the way to the right. So if you see this notation, it is on the right-hand side. I'm trying to get that glare to go away. It's right where I need for you to see. All right, but this says that it's from -infinity to -2. It's below the x-axis. That crazy looking N is the symbol for and. So that means I have another piece that's also below the x-axis. And from 2 to +infinity. I'm going to post a picture of this on Edmodo, so if any of this is difficult to see, you can pull up that picture. All right, maximums or minimums. This graph does not have any minimums. The y values are going to go down forever and ever and ever, so you're never going to bottom out. Like, you're never going to reach a lowest part of this graph. Technically, it looks like this would be a minimum, only because it's smaller than that point. But that open circle means it's not included, so I can't use that as a minimum. Same thing over here. It looks like this should be a minimum because it's smaller than that, but it's not a real point because it's an open circle, so I can't use that. The only maximum or minimum that I have is this point right here. This is absolutely the highest point on this entire graph. So the point 1, 3 is called an absolute maximum. There's no point on this whole graph that's any higher than that. And it's a closed circle, so that means you're allowed to use it. All right, the intercepts. Your x-intercept is wherever it crosses the x-axis. So it crosses at -2, 0 and at +2, 0. So there's that and symbol again. And your y-intercept is where it crosses the y-axis, and that happens at 0, 2. If you notice for your x-intercept, your y is 0, and for your y-intercept, your x is 0. All right, so I know that that's a lot of things, but we're going to practice this for the next 2 days. So please read over the right-hand side for 4.2 and make sure that you can connect all of these things that we talked about in this graph to what you have for 4.2 and the parent function that you were assigned with your group.